Okay, good afternoon, everyone. I have two questions for you to start. Have you ever felt like you had this great idea for a data science project? However, you found it difficult getting it adopted? Show of hands, anyone? Okay, a couple of people here. Second question. Perhaps you had to explain some data insights to a non-data science team and you found it complicated. Ever? Anyone? Okay, so this presentation is for you, okay? But just for a moment, let's imagine the data science field as a dating scene. Every project is a new relationship brimming with promise and excitement. But just like in the world of romance, communication can be riddled with misunderstandings, misaligned expectations, and the occasional heartbreak over the wrong assumptions. So because of that, let's delve into the major communication challenges that we have between data scientists and business leaders, and what do well-matched teams do to solve these issues. Problem number one, the blind date with vague requirements. So imagine that you're delving into the world of online dating. You downloaded a new app and you want to find someone fun and interesting. You download the app, you install the app. Okay, this is still here. You download the app, you install the app, you log in, you're eager and hopeful, just to find a myriad of profiles that are nearly blank. Just a sparse photo here and there, and hardly a hint about who these mystery daters might be or what they might be looking for. Can you feel it? Expectation, reality? That's exactly what a data scientist feels when he's starting a project and he finds that he has vague requirements. But what is a vague requirement? An example. Imagine that your company wants to build a model to define which customers they should target in a marketing campaign. Beforehand, business leaders should define if they want to target customers that are likely to transact, that is, frequent customers, or customers that are likely to transact if campaigned but not otherwise. Depending on the answer that you have, the effort, the data that you'll use, the model approach, and especially the impact that it will have on your business will be totally different. So what do? We all know that it's very important to have a very well-aligned scope, requirements, deliverables, etc. But the secret for me is to start with a story that is easy to understand and that basically explains your problem to everyone. How do you do this story? For me, you have to start with two main questions. Question number one, how would your data team would solve this problem if they didn't know any data science? Let me give you an example. Imagine for a moment that you're building a recommendation tool for your e-commerce website. Okay? A simple baseline that you'd have is that your team would track the products or the categories that are highly searched by customers, and for each one of those categories, they would recommend top-selling products. Second question, who will be using this data? How will they use it? Let's skip the recommendation tool and imagine for a moment that you just want a churn dashboard. A churn dashboard should give you information regarding which customers have higher probability of leaving your company. Who will use this? Probably your marketing team with the intent of talking to those customers before they leave and avoid that they drop your company. Problem number two, the messy breakup with poor data quality. So, you finally have a date just to discover that your data's profile was highly embellished. Data or the details were misleading or outdated. Similarly, in data science, starting a project with very poor data quality is like starting a relationship in a shaky foundation of lies. You see, data is the base of all analysis and all the models. And if data is too inconsistent, it can really jeopardize your project. Let's see an example. Imagine for a moment that you're trying to predict traffic patterns. This time, while you're analyzing your data, what you discover is that data has many errors because sensors are poorly calibrated. What does this mean? So you have to recalibrate the sensors. You have to gather new data, and that takes a long time. And finally, you'll be reviewing your model. So basically, you can say goodbye to this lovely project. What can we do about this? Anything? So the secret here is to make time for feasibility assessments. While you don't know everything about the data that you have, you will at least know some of the knowns and knowns. And what you want to do here is answering the main question, which is, given the data that I have, can I try to solve this problem? Or how far can I go and where do I do the cutoff? Problem number 3. Scope things. Here today, gone tomorrow. So, for a moment, imagine that you just came back from Germany and you and your partner agreed that you'd stay home for the weekend. Very tiring trip. However, upon your arrival, your partner decides that you're going to have dinner with friends, you're going to the movie, and perhaps even a weekend getaway. Can you imagine the situation? That's akin to scope changes in data science. But why does this happen? Well, when you start a data science project, many times you make new discoveries that create new requirements. And here, the simple thing is you have to manage it. How do you manage this? By show of hands, do you have any married people in the room here today? We must have married people in the room. So, it can't be that bad. You all signed the contract, right? So you know where I'm going. Oh, I forgot the example, but okay, I can give you the example and then I'll go back. So just to give you the example, what is a scope change? Imagine that you're developing a classifier for phone cases, okay? So according to the image and the title, you have to classify your products. But during your data analysis, what do you discover? You discover that you have phone cases under phones and accessories, but also under accessories. What does this mean? That right now, you'll have to do some extra data cleaning, and you also have to refactorize the category tree. So back to the solution. The solution is you must know that writing is expensive, but cheap. You know, many times, people avoid too much documentation because you want to be very agile and very adjustive. But the thing is that having a proper backlog many times saves you a lot of time. What is saving time? Because you might lose 1 week, one afternoon, or whatever, but that really enables the team to work on what you want them to work and not on something else that many times is not needed. So what do? You write everything, you update everything, and you track everything. And that's for your backlog. And if there are any changes or any new needs, you just update them. Problem number 4. Love at first code, not in data science. So think back to your teenage years when you fell madly in love with some rock star or a Hollywood icon. Do you think that if you met them back then, they will match your expectations? Probably not. Likewise, in data science, first impressions do not serve to gauge for the future. For instance, many times there's the expectation that after an agile sprint, you have to have tangible deliverables, like it happens in software engineering. But the thing is that in software engineering, what do you have is well-defined tasks and well-defined outputs, like a button or an interaction. In data science, on the other hand, what you have is more exploratory work, hypothesis testing, model testing. And the outputs many times are new learnings, next steps, research findings, etc. So the big question ends up being, if you don't have a tangible output, how do you know that work is progressing? How do you share updates? You have to reframe the project's breakthroughs. And you do this with 3 questions. What did you do? How did you do it? And why did you do it? And why are these 3 questions important? Because they give you scope, methodology validation, and they give you impact assessment. Secret number 5. Have you ever been ghosted? Not in dating, but suppliers, the government, the plumber, services, wherever. It's not nice, okay? It's not nice, by the way. In this case, what we have is that data teams serve as a bridge between several different teams. They work with business leaders, they work with data engineers, they work with IT. What does it happen? That many times you have some problems in getting the information or the access that you need. For instance, you might need some data from another department and you don't have it, but you need it to advance your project. You might have some communication gaps with data engineers when you want to build a data platform and it doesn't match your requirements. Or perhaps you need access to some software and some IT, and the IT is not really giving it to you. What's the secret here? Well, if you come back to dating, what do you expect when you meet someone for the first time? You expect courtesy, you expect kindness, you expect fun. Also, if you meet a new potential business partner, you invite them to have lunch because you want to engage, you want to create a connection. And the same thing goes for team collaboration. So I really don't care if you open the bar every Friday and you close it every Friday, but you need to create really good relationships between the different teams. And that's very important because when you have a better relationship, you increase the trust, you increase the engagement, and ultimately you'll have better results. Final problem. Lost in translation. Have you ever dated a foreign partner? A girlfriend or a boyfriend from a different country? Have you ever had to explain your feelings in a different language? This is one of the main barriers between business leaders and data scientists. Business leaders know KPIs, know business context, know industry trends. Data scientists know algorithms, statistics, Python. And many times having to explain this business context or having to explain these algorithms might be a little bit difficult. Like when you have to explain what is a confusion matrix, what is a Markov chain, or as a business leader, you have to explain them how to compute solar radiation for solar panels. So, final advice. Many times, the answer that I have in projects that I've been running in my company, it's like, I went 50%, and I was expecting that they went 50%, and somehow we would meet halfway. But here the gap is so big that what is most likely to happen is that they go 1% and you have to go 99%. Okay? And that's okay because it's a journey that you build together and you're not working for them, you're working with them. Okay? So here, this many times, what does it mean? It means that business leaders many times have to explain the obvious for them in industries, and data science teams need to waste some time detecting some presentations before they update the stakeholders. So, wrapping up. For better business requirements, create a common baseline. If you want to avoid problems with data quality before delving into the real project, make time for feasibility assessments. For scope changes, always write everything, okay? Reframe projects breakthroughs to make your project updates. And to avoid being ghosted by silos, create better relationships. And for big translations, just meet people where they are. I think that if you follow these tips, you totally got this. And always remember, just like a date, a new project is the promise of something great.